Once again, folks, let's dive into the last problem on momentum. We have two particles P and Q of masses 2 meters and m, 2 kilograms and m kilograms respectively are held at rest in the same vertical line. Heights of P and Q above the horizontal ground are 1 meters and 2 meters respectively. Now P is projected vertical upwards with speed 2 meters per second. At the same instant, Q is released from rest. Find the speed of each particle immediately before they collide. So we're interested in speed before the collision. So we need a bit of a sketch here to say we have a height of 2 meters above the ground. Because somewhere at 1 meter, there we have object so P is 1 meter above the ground. So P is here, and Q obviously is 2 meters above the ground. And the object P is projected upwards with an initial speed of or its initial speed u of 2 meters per second, and we know Q is coming from rest, that's 0, and free falling G will be 10, and here G is a negative 10, what is going against gravity. And one thing to notice, if free falling is positive and we have treated our U as positive, then it means going upwards, B we expect it to be negative, so that's negative 2. So we're interested in the speed of particle immediately before they collide. Then we are going to say maybe the collision happens somewhere where Q we have moved h meters. So what it implies is P we have moved 1 minus h, so that when we add the 2, they give us a 1. But what we know is that the time at which these collisions happen is going to be the same. So using our equation S equal to ut, we'll try and do for both. We can start with object Q to say, let's have a look at the time when these two collide. So once we have the time, I think we can find the final speed. So let's have a look. We are going to say object Q. What's happening on object Q? Using the formula S equal to ut plus half at squared. We know Q is going to move h meters, so it's h equal to, initially it was at rest, so this whole part becomes 0, so we end up having half multiplied by acceleration due to gravity multiplied by t seconds that we spoke about. And when we simplify, in essence, h is going to be 5t squared. Let's try and do the same for object P. Object P, we are going to say, using the same formula, we say for object P, S, which is 1 minus h, is going to be, initially it was moving at 2, and 2 time plus half, half a, but this time around a is minus 10 times t squared. And when I simplify, I have 1 minus h equal to 2t minus 5t squared. Then when I combine these two simultaneous equations, let me take this one. Let me take this one and put it below. And it's 5t squared. So when I sum in column form, these h's are going to cancel, end up having 1 equal to, these two, they cancel, we end up having 2t. So our t is actually 0.5 seconds. So what's our interest? We want to check what happens when h is moved t seconds. T is 0.5. So our h, know why we're interested in. Well, let's leave h for now. Maybe we can bring the first equation, because we now have u, a, and t. So our interest was on final velocity v. So before collision, v is equal to u plus at. But u initially, object q was at rest. Think object, was it object q? Q is the one which is projected vertically, so Q is released from rest. So Q is the one which was at rest. So plus acceleration, which is 10, multiplied by the time, which was 0.5. So final speed of Q will be 5 meters per second. Then for T, if we use this same thinking, we can choose to say the final speed there is going to be, again, we use the same formula, V equal to U, but initially it was 2. So 2 plus, but remember it's going upwards, so acceleration is minus 10 multiplied by 0.5. And when we simplify, we get actually 2 minus 5. So the final speed will be minus 3 meters per second. So it looks like it will have changed direction. It will be moving downwards in 3 meters per second when the two collisions happen. So for speeds, we will take the modulus, implying VQ, sorry, VQ, or speed of Q before collision is 5 meters per second, and VP before collision is actually 3 meters per second. Moving to the second part, it's given that immediately after collision, the downward speed of Q is 3.5 meters per second. Find the speed of P at the instant that it reaches the ground. So immediately after collision, we have the speed. So we can come to say, but speeds before collision, we had 5 and 3. So we can come to say, for object Q, its speed was object Q. Let's come and have a look. Object Q, its speed was 5. What about its mass? Object Q, object Q's mass. The object Q, I'm sure is the one corresponding to this mass, so it's M. So I can come to say 5M because its speed was 5. So 5M plus the speed of Q was uh, 3, but remember the mass is 2M being equal to, so this is P, this is Q. After collision, we are told Q is moving at 3.5, so it's 3.5, but the mass is M plus, wow, we don't know the speed of T, but its mass is 2M. So we can say 2mv like that. And when I do my simplifications, I'm going to get 11 here minus 3.5 all over 2. That will be the new speed. Let's try and have a look. 11 minus, it was 6. Well, 11 minus 3.5, sorry. 3.5 giving us 7.5. Then we divide this by 2. It looks like it gives us 3.75. So the new speed is 3.75. That's the speed of P, 3.75 meters. Find the speed of P at the instant that it reaches the ground. So our interest might be, but before they collide, how much distance they covered? And we know all this happened in a time of half second. Half second. We go that time here, that it was half of a second. Then we can choose to say, wow, which one was free falling? You can target the one that was free falling. That's object Q. Object Q had moved downwards 5 times time squared. So 5 times time squared is object. See the object that moved time. That's object Q. Object Q, it moved 5 times time squared. So for object Q, it moved a height of 5t squared. And we know the time, it was 0.5 seconds. Therefore, object Q downwards, it went 5 times 0.5 times 0.5. We're saying 0.5 squared. Sorry, let me redo this. We are saying 0.5 squared multiplied by 5. It gives us 1.25. 1.25. So in essence, we are saying if this is 1.25 meters, what it implies is of the 2 meters, what was remaining is we can say S to be covered. It will be 2 minus 1.25, which is actually 0.75 meters. So we are interested in the speed of P reaching the ground. So initially it's moving at 3.75 meters, 3.75, but it wants to cover a distance of 0.75, but it's free falling. So we are going to say the final velocity, which is what we want. We want the speed. So final velocity, when we know the initial speed and displacement, I'm sure the favorable formula will be v squared equal to u squared plus 2as. V squared is what we are looking for, but initially it's 3.75, but we are squaring it plus 2 multiplied by 10 multiplied by 0.75. So when I bring my calculator, V is actually, let me bring my calculator, we are saying root of 3.75 squared plus 2as, 2 multiplied by 10 multiplied by 0.75. Can I move out of the root sign and check what I get? If I make a decimal, it's giving me 5.39 or 5.4. So the speed will be 5.39 meters per second. I think that's it on the third series. Thank you, folks, for following up. We'll meet in the next section, which is likely to be work energy power. Bye.